48 hours ago, at exactly 9:14 UTC, something was detected in deep space that does not fit within any known law of celestial mechanics. The Deep Space Network Station in Canberra, Australia picked up a data signature that should not exist. This was not a comet cracking apart under solar stress. It was not tidal disruption. It was not random fragmentation. What occurred was a synchronized, powered divergence event involving the object known as 3I Atlas. For months, 3I Atlas had been tracked as a single, stable interstellar body. Its trajectory was mapped, its velocity modeled, its mass estimated. Nothing about it suggested instability. Then, on February 27th, as it crossed the frost line roughly 450 million kilometers from Earth, the impossible happened. It did not simply split. It executed what can only be described as a maneuver. NASA's tracking data confirms that the original mass separated into two nearly identical bodies. We now call them Atlas Alpha and Atlas Beta. In every documented natural breakup, debris disperses chaotically. Momentum is conserved. Fragments drift along variations of the parent object's path. But that is not what happened here. Atlas Alpha banked sharply left, altering its orbital inclination by 14 degrees relative to the ecliptic plane. Atlas Beta banked right, adjusting by negative 14 degrees. They did not drift, they accelerated. And here is the detail that changes everything. Both objects, despite diverging in opposite directions, now have calculated arrival vectors that intersect Earth's orbit at two separate points. Pause for a moment and consider that. Nature does not coordinate like this. Ice does not calculate intercept geometry. Rocks do not perform synchronized orbital adjustments. Within 19 minutes of the split, the James Webb Space Telescope redirected its instruments toward the event. What it recorded silenced the control room. There was no debris field, no expanding dust cloud, no chaotic bloom of gas. The separation was clean, precise, surgical. The probability of a comet naturally dividing into two equal halves and immediately accelerating onto divergent Earth-intersecting paths is less than 1 in 8.4 billion. Statistically, you are more likely to win the Powerball lottery 3 consecutive times than witness this behavior by chance. So, if this was not chance, what was it? Public statements from scientific institutions use cautious language, anomalous fragmentation, non-gravitational forces. But when you examine the raw telemetry, the conclusion becomes far more difficult to soften. Atlas Alpha registered a velocity increase of 4.2 kilometers per second in vacuum without visible outgassing. Acceleration requires energy. Energy requires a source. We are no longer observing a passive object passing through the solar system. The geometry resembles a pincer movement. Two bodies separating symmetrically, adjusting inclination deliberately, both aiming toward Earth's orbital path. At this point, the most important question is not how it happened. The physics already challenge our models. The deeper question is why. To understand how unnatural this event truly is, compare it to known cometary disintegrations. When Comet Atlas fragmented in 2020, or when Ison broke apart in 2013, the process was chaotic and violent. Megatons of dust and volatile gases erupted outward, the coma brightened dramatically, sensors across multiple wavelengths detected turbulent expansion. Natural breakups are messy, but on February 27th, 3I Atlas separated without chaos. At 14 UTC, the James Webb Space Telescope's NIRSPEC instrument analyzed the region. Scientists expected to see an expanding cloud obscuring the nucleus. Instead, infrared data revealed two distinct solid signatures with an almost perfect vacuum between them. Dust density in that gap measured less than 0.000004 particles per cubic meter. Two objects, each approximately 1.2 kilometers in diameter, altered their trajectories by 14 degrees and produced virtually zero debris. Thermodynamics does not allow that. The only plausible mechanism for a separation this clean is not internal pressure, it is controlled release. And what the next 6 hours revealed would force the scientific community to consider a possibility no one is comfortable saying aloud. Because once the separation stabilized, independent observatories began cross-verifying the event. This was not a single instrument glitch. It was triple-source confirmation. First, the James Webb Space Telescope confirmed in the infrared spectrum that there was no dust plume, no particulate plume, no expanding coma. Second, the Atacama Large Millimeter Array in Chile 66 synchronized high-precision antennas locked onto the object to measure carbon monoxide outgassing. In a natural comet split, gas production spikes dramatically, often by 300 to 500%. But ALMA recorded no spike. Gas output remained stable, divided evenly between Atlas Alpha and Atlas Beta, as if rationed. Then came the third observation. The Chandra X-ray Observatory detected a localized burst of hard X-rays between the two bodies at the exact moment of separation. The pulse lasted 0.4 seconds. It was sharp, contained, focused. Three independent instruments, using entirely different detection methods, confirmed one impossible conclusion. This was not collapse. This was deployment. When analysts calculated the mass distribution of the two fragments, the result deepened the mystery. In every documented natural breakup, one fragment dominates while smaller pieces scatter. Here, data from the Gaia spacecraft showed that Atlas Alpha and Atlas Beta were identical in mass within a margin of error of 0.02%. It resembled cellular mitosis, one becoming two, symmetrical and balanced. In millions of simulated cometary events, a perfect 50/50 mass division, followed by immediate velocity adjustment, has never been recorded. Then, 6 hours after the separation, something else changed. At approximately 20 UTC, the Deep Space Network updated trajectory models. A natural fragment drifts. It follows inertia. But Atlas Alpha began rotating in a stabilized axis lock. This was not chaotic tumbling. Light curve data, the brightness variation as the object spins stabilized in under 40 minutes. Natural tumbling dampens over weeks or years. Atlas Alpha achieved rotational stability in less than an hour. It aligned its long axis, perpendicular to the Sunday. That orientation maximizes solar radiation pressure, effectively turning the object into a solar sail. Meanwhile, Atlas Beta did the opposite. It aligned parallel to the Sun, minimizing its reflective cross-section. One expanded its profile to catch radiation. The other narrowed its signature. One became bright and obvious. The other became dark and discreet. Why would two halves of the same object adopt opposite aerodynamic profiles unless their objectives differed? Trajectory models suggest Atlas Alpha is designed to arrive first, visible, luminous, attention-grabbing. Atlas Beta appears optimized for quiet approach, minimal detection, reduced tracking signature. When examining their separation rate, currently widening at 12,000 kilometers per hour, the geometry becomes more concerning. By the time they approach Earth's vicinity, they will flank the planet from opposite celestial hemispheres. And then came the most unsettling data point yet. It was not the split, not the acceleration, not even the synchronized rotation. It was the silence between them. Because buried in that silence, radio telescopes detected something no one expected. And when that signal was analyzed, the interpretation shifted from anomaly to coordination. On February 28th at 3 UTC, The Green Bank Telescope in West Virginia detected a narrowband radio emission centered precisely between Atlas Alpha and Atlas Beta. This signal was not predicted. It was not modeled. It was not random noise. It was coherent. To understand the significance, consider the frequency 1.42 GHz. This is the hydrogen line, often referred to as the water hole, a region of the electromagnetic spectrum long considered optimal for interstellar communication. Comets emit broadband static as ice sublimates. They do not transmit narrowband signals locked to a single frequency for 12 continuous minutes. But that is exactly what occurred. The signal was not directed at Earth. It was directed at the other fragment. When analysts examined the signal strength pattern, they noticed something precise. The amplitude oscillated in perfect synchronization with Atlas Alpha's rotation every 4.2 seconds. Pulse, 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 a repeating handshake. Then, at 3:15 UTC, the signal stopped, and immediately afterward, both objects executed a maneuver that violates classical orbital mechanics. In a vacuum, an object follows a ballistic trajectory governed by gravity. It accelerates toward massive bodies and decelerates as it moves away. But Atlas Beta, the darker, quieter fragment, accelerated away from the Sunday. Non-gravitational acceleration of this magnitude is unprecedented. The measured force was approximately 400 times stronger than the subtle anomaly observed with Oumuamua in 2017. Acceleration without visible exhaust presents a problem. There was no plume, no gas release, no chemical signature. If this motion is driven by radiation pressure alone, the efficiency would need to approach near-perfect reflectivity. Ice reflects roughly 60 to 70% of sunlight. To achieve the acceleration observed, approximately 4.2 kilometers per second squared, the surface would need to reflect nearly all incoming radiation with nanometer precision smoothness. Nature does not polish kilometer-scale objects into mirrors. Now, examine the geometry. Atlas Alpha's projected path intersects Earth's orbital corridor from the northern hemisphere approach. Atlas Beta intersects from the southern hemisphere vector. In strategic terms, this resembles a pincer configuration. One bright, one dark, one obvious, one subtle. Orbital simulations project closest approach on July 14, 2026. The two objects will not arrive together. They will bracket Earth from opposite sides, separated by approximately 1.2 million kilometers. The estimated margin of arrival timing is less than 4 seconds. After traveling billions of kilometers, after splitting symmetrically, after accelerating independently, they are synchronized to intersect their respective coordinates within seconds of each other. That degree of coordination requires feedback, real-time adjustment, continuous correction. If this were natural fragmentation, tiny random differences would compound over distance. One fragment would arrive days earlier, the other weeks later. Chaos would dominate the timeline. Instead, they remain locked. And then the next discovery transformed this from anomaly into potential interaction. Because hidden beneath that loud 1.42 GHz handshake was something else, something aimed not at each other, but directly at Earth. On March 1st at 5:42 UTC, the SETI Institute's Allen Telescope Array in California identified a second, fainter signal buried beneath the primary transmission. It was subtle, nearly lost in background noise, but once isolated, its structure became clear. This was not random interference. It was patterned, directed. And here is what changed everything. The signal was not continuous, it was reactive. Analysts cross-referenced its timing with terrestrial radar activity. Every time a major Earth-based radar system transmitted a tracking pulse toward Atlas Alpha or Atlas Beta, whether it was the AN, FPS 85 space surveillance radar in Florida or the Globus MN system in Russia, a return signal was detected within 0.08 seconds. That delay is critical. If this were a natural comet, the radar pulse would scatter randomly, diffusing across frequencies. Ice and rock cannot receive, analyze, and transmit a modified response on a separate frequency band with near-perfect coherence. That behavior requires processing capability. In under a tenth of a second, the object received our signal, interpreted it, and sent something back. If this is natural, physics must be rewritten. If it is artificial, then it is scanning us. Within 3 hours of confirming this correlation, NASA made an unprecedented move. The public Deep Space Network, live stream operational for decades, was shut down. The explanation given was routine maintenance. In 50 years of operation, such interruptions have been exceedingly rare. The timing was not random, because while the public focused on the dramatic orbital shifts, researchers uncovered something even more concerning in the signal pattern. The 1.42 GHz transmission between alpha and beta had stopped. Why would a synchronization signal abruptly cease? There are only a few possibilities. If it was a diagnostic exchange, then the system check is complete. If it was a handshake, then the connection has been established. And if it was a targeting lock, then the calibration phase is finished. There is no neutral interpretation. Meanwhile, the geometry continues to tighten. The two objects are approaching Earth's orbital path at a combined separation rate that keeps them perfectly bracketed. Every hour reduces the gap between their intercept vectors. Current projections show closest approach on July 14, 2026, with arrival timing synchronized within 4 seconds. After billions of kilometers, symmetry persists, and as of now, both objects are accelerating. But acceleration toward what? Let us pause and establish what we know with certainty. We have two objects of identical mass that separated without debris. Both executed non-gravitational maneuvers, altering their inclination by exactly 14 degrees in opposite directions. Both stabilized rotationally within minutes. Both adjusted their surface orientation relative to the Sun to optimize or minimize radiation pressure. Both are synchronized to intersect Earth's orbital corridor within seconds of each other. And both have demonstrated reactive radio behavior consistent with signal processing. These are not speculative theories. They are documented observations from the most advanced astronomical instruments humanity has ever built. Now consider the implications of that 0.08-second radar response time. Light travels roughly 24,000 kilometers in that interval. That means the object received the signal, processed it, and transmitted a modified return almost instantly. The onboard computational capability required for that reaction rivals our most advanced terrestrial supercomputers. And then there is the reflectivity issue. To achieve the measured acceleration through solar radiation pressure alone, the surface of Atlas Beta would need reflectivity approaching 99% efficiency. Ice cannot achieve that. Rock cannot achieve that. Even our most advanced telescope mirrors require precision manufacturing to approach such smoothness. Nature does not polish kilometer-wide bodies to nanometer tolerances. Meanwhile, orbital simulations reveal something even more precise. When projecting 4 months forward, both objects cross Mars's orbital path within 3 weeks. That is the next checkpoint. If any braking maneuver or trajectory correction is planned, it must occur near that crossing. The margin of error for their July 14th Earth intercept remains under 4 seconds. That level of precision over astronomical distances implies continuous micro-adjustments. Random gravitational perturbations from Jupiter or Saturn would normally introduce timing drift measured in hours or days. Instead, the synchronization holds. And here is what makes researchers uneasy. The signal between alpha and beta stopped not because it weakened, but because it completed its pattern cycle. Silence is not absence. Silence is conclusion. Now, telescopes across the globe are locked onto these two objects. The Green Bank telescope is monitoring for renewed transmission. The Deep Space Network is tracking velocity changes in real time. The data stream continues, but the radio channel remains quiet. Which raises a final question. If the calibration phase is finished, what phase comes next? The clock is running. As you watch this, Atlas Alpha and Atlas Beta continue their approach. Each hour reduces the distance by another 12,000 kilometers. In exactly 3 weeks, they will cross the orbit of Mars. That crossing is not symbolic, it is strategic. It is the final major gravitational boundary before Earth's orbital corridor. If a braking maneuver exists, it must begin there. If there is no braking maneuver, then July 14th becomes unavoidable. Let us revisit the synchronized geometry one final time. Two objects of equal mass. A debris-free separation, identical but opposite inclination changes of 14 degrees. Stabilized rotational axes within 40 minutes. Solar alignment adjustments suggesting intentional radiation management. A 1.42 GHz synchronization handshake. A secondary radar response in under 0.08 seconds. Arrival timing synchronized within 4 seconds after billions of kilometers of travel. Each of these alone would qualify as anomalous. Together, they form a pattern, and patterns imply design. Even Avi Loeb of Harvard, one of the most cautious voices in interstellar object research, stated publicly that the statistical likelihood of this being a natural gravitational encounter is vanishingly small, and that the artificial hypothesis must be considered. When language like that appears in official discourse, it signals a shift. Meanwhile, NASA's redirection of Deep Space Network resources exclusively toward these two objects has halted other scheduled observations quietly. Without announcement, the White House classified briefing this morning was not about impact probability, it was about intent modeling. Because if this is natural, it is the rarest coincidence in recorded astronomical history. If it is artificial, it is the first documented instance of coordinated non-terrestrial technology entering our solar system. And the signal has stopped. That is the detail that matters most. If it was diagnostic, the test is complete. If it was a handshake, the connection is established. If it was target acquisition, then the system is locked. There is no middle ground. Right now, instruments worldwide are recording every photon, every frequency fluctuation, every micro-adjustment in trajectory. The data is flowing, even if public channels are silent. T-minus 135 days to July 14th. T-minus 3 weeks to the Mars crossing. Whatever 3I Atlas truly is, visitor, probe, coincidence, or something we have not yet imagined, we are about to find out in real time. And when the next maneuver occurs, when the next signal breaks the silence, you will want to understand exactly what it means. So stay informed, follow the data, subscribe, and turn on notifications, because the next update may redefine not just astronomy, but humanity's place in the universe.